Hello, today we're going to talk a little bit about time value of money, which is basically just referring to how the value of your money changes over time. Due to inflation, your money can lose value, but if you make smart investment choices due to interest you are getting paid, your money can grow over time. And so we're going to look at examples of both money gaining and losing value by using formulas that involve time value of money. I've also posted a PowerPoint to Canvas that has a little more detail here other than what you just see here for the reading. For this video, though, we're going to focus on the example problems. The first one should feel very familiar, this investment example right here. It says to invest $100 for 1 year at 5% interest. This is something we've seen before. The amount you have at the end of 1 year is the interest you get paid, which is principal times rate times time, plus your starting principal amount. So since we are investing $100, our principal is 100, rate is 5%, which as a decimal is the same 0.05. Time is 1 year, so times 1. And then plus that principal once again, which is $100. You might be able to do this in your head, but we can use Desmos just for safety. You can type in everything exactly the way you see it. And so if we invest $100 for 1 year at 5% interest in a simple interest situation, at the end of that year, we have $105. Something that you think about with investments is the future value of your money. So here, this capital X is your amount you've invested. When we multiply that by 1 times the rate as a decimal, we get the future value of your money. If you are dealing with compound interest, instead of just being our amount times 1 plus the rate as a decimal, we then have two things happening. We have this exponent, which is the total number of periods. So for instance, if your interest is being compounded quarterly, that'll be 4 times a year times however many years you're dealing with. And the other key thing here, which I almost forgot when I was doing some of these calculations, is that when you're dealing with compound interest, the rate must also be divided by the number of periods per year. And so we'll see this in context here. In this example, Leo owes his mom $50 for 53 years. The interest is compounded quarterly at 5%. Find the future value after 53 years. So the future value is going to be the amount that he is loaning, or he has borrowed $50, times 1 plus our rate here is 5%. So once again, that's 0.05. But since we are compounding quarterly, I need to take that rate and divide it by 4. And then up in an exponent, our number of periods, it's 53 years, but quarterly. So to find the number of quarters in 53 years, we are going to do 4 times 53, which you might want to use decimals for that, which is 212. So the number of periods here is going to be 212. So I'm going to have 212 up in the exponent. Would highly recommend you do this in Desmos so you don't have to try to do a 212 power in your head. So type in exactly what you see, 1 plus, get that fraction, we're going to do 0.05 divided by 4. And then outside of the exponent, I'm going to show you here real quick. To get that exponent in Desmos, it's been a while since we've done exponents. To get any exponent other than squared, we hit this A to the B button, and notice it pops your cursor up here into the exponent space. So our exponent is 212. And since we are dealing with money, we are going to round this to the near hundredth or 2 decimal places or nearest cent, however you want to think of it. $696, 0.172 rounds to 17 cents. So you start off only owing $53, or only owing $50, but over the course of 53 years, with the interest being compounded quarterly, that amount became nearly $700. Last small concept here we're going to talk about is present value. So the equation we're going to use is right here, very similar. And just like with when we were dealing with future value, your rate here needs to be divided by the number of periods per year. So we're out of these, which one has the highest present value? And this, of course, over time, your money will lose value. And so we're going to compare But if I give you $800 right now, $1,000, but you don't get it until 3 years now, $2,000, but you don't get it for another 10 years, or $3,000 and you don't get it for 20 years. So which of those is the most valuable in the present moment? 800 today stays 800 today. Since we don't have any number of periods, any compounding or anything happening, this one is just straight up $800. Looking at letter B, $1,000 3 years from now, its present value would be the future value, since it's going to be $1,000. That goes up top. 1 plus R is going to be 1 plus 10% as a decimal is 0.10. And since it's annually, we would divide by 1. 0.10 divided by 1 is just 0.10. And then number of periods, it's 3 years, so we're going to have 3 in the exponent. So let's do that in Desmos. We need a big fraction to start with. 1,000 goes on top. And then here, 1 plus 0. Oops. I am typing like a crazy person right now. 1 plus 0.10. Close your parentheses. Hit your A to the B button to get your exponent 3, and round it to the nearest cent. That becomes $751.31. So far 800 today is looking the best, but let's check the other two. For the next one, $2,000 10 years from now, we're going to follow the same format. This time this is $2,000, 2,000 goes on top. Down the denominator is still the same percentage rate, so 1 plus 0.10. But since it's 10 years, we're going to have a 10 exponent here. So doing that in Desmos, division sign to get your fraction. 2,000 divided by 1 plus 0.10. Close your parentheses. A to the B exponent 10 gives us $771. And when we round that, 0.086 is the same as 0.09. And then the last one, $3,000 20 years from now, same idea. 3,000 up top divided by 1 plus 0.10. Since it's 20 years, 20 will be our exponent. So division 3,000 divided by 1 plus 0.10. Close your parentheses. A to the B for your exponent. This time it's 20. That gives us 445.93 when we round. So out of these, the one with the highest present value is $800 today. The other ones, even though it sounds like more money, because of inflation, at the end of that time frame, it'll be like this amount in present dollars, which is all smaller than what you think you're getting. That is it for time value of money. Have a fantastic day.